Hello science lovers, welcome back to the channel where curiosity meets clarity. Today we're diving into one of the strangest, most fascinating ideas in all of physics, time dilation. Yes, it's real. And no, you don't need to be traveling through a wormhole or piloting a spaceship at warp speed to appreciate it. All you need is a mind open to one of the most beautifully bizarre consequences of Einstein's theory of relativity. So buckle up, because by the end of this video, you'll never think about time the same way again. Let's start with the basics. Time dilation is the idea that time doesn't pass at the same rate for everyone. It slows down depending on how fast you're moving or how close you are to a massive object. This isn't science fiction. It's a fundamental prediction of Einstein's special and general theories of relativity, and it's been proven experimentally many times. But how can time change? Isn't a second always a second? Well, not quite. To understand time dilation, you need to understand something else first. The speed of light is the ultimate speed limit of the universe. According to Einstein's special relativity, the speed of light, about 209,792 kilometers per second, is constant. No matter how fast you're moving, light always seems to travel at the same speed relative to you. But in order for that to be true, something else has to give. And that something is time. Let's say you're on a spaceship zooming at 90% the speed of light. You shine a flashlight forward. Weirdly, someone standing still, say floating in space, will measure that light moving at the same speed as you do. How? The only way to reconcile that is for your experience of time and space to stretch and contract compared to theirs. This leads to time slowing down for you relative to someone who's standing still. Here's a classic example, the twin paradox. Imagine you have a twin. One of you boards a spaceship and travels close to the speed of light, goes out into space and comes back. The other stays on Earth. When the spacefaring twin returns, they've aged, let's say, 5 years. But the twin who stayed on Earth has aged 10 years. You're still twins, but you're now biologically 5 years apart. That's time dilation in action. And it's not just a thought experiment. Scientists have actually tested this using atomic clocks on high-speed jets and satellites. The moving clocks tick ever so slightly slower than the stationary ones. But there's another way to slow down time: gravity. That's where Einstein's general relativity comes in. According to this theory, massive objects like planets and black holes warp space and time around them. The stronger the gravity, the slower time moves. Right now, time is passing slightly faster for your head than for your feet, because your head is a little farther from the center of Earth's gravity. This might sound insignificant, but GPS satellites, which orbit thousands of kilometers above Earth, have to correct for both gravitational and velocity-based time dilation to keep their clocks in sync. Without those adjustments, your GPS would be off by kilometers every day. So why does this matter? Time dilation isn't just a cool physics trick. It shows us that time is not absolute. It's relative, tied to the speed you're moving and the gravity you're feeling. This means that in a universe where people can travel at near light speeds or orbit near black holes, time itself can be experienced very differently. If we ever become an interstellar species, we might see explorers return home to a civilization that has aged decades while they've only experienced a few years. And maybe that's already happened somewhere out there. So next time you're running late, just remember, somewhere in the universe, you might actually be early. Time dilation is one of those rare scientific ideas that's not just mind-bending, it's true. If you found this fascinating, hit that like button, subscribe for more Science Explained, and tell me in the comments. If you could travel near the speed of light, where would you go? Until next time, stay curious and keep exploring.